to group. Okay, you make the group frequency table so that your number of classes is limited, and you have at least a short and presentable table. Okay, so with this, in order for us to make the group frequency table, we need to determine the number of intervals that we are going to use per class. Usually, for uniformity, classes are indicated in the problem, okay? But when you are doing your own research, limit the number of classes to be less than 10, okay? That is the recommended one. Number of classes for group frequency table is less than 10. So for this set of data, let us use 8 classes, okay? Oh yeah, one more thing. Frequency tables are, or and group, group frequency tables are usually used for a large number of data sets. But even if we have large number of data sets, it doesn't mean that we are using the entire population for the research. For example, if I want to make a study on the favorite food of female students of Mondial, okay, if I'm going to think about it, how many female students do we have in Mondial? Only one. Female students in Mondial. So we have that as your population, take all those 1,000 students. Okay. So if I will say I'm just going to interview around 100 of them, and then whatever the result is, I'm going to generalize that that is the result for all of the female students of Mondial. So that means from 1,000 students, I'm just going to get 100 students. The 1,000 students is called the population. Population, usually denoted by the capital letter N for the population. And the part that I took out from the population, this is now called your sample. Sample population denoted by the small letter N. Okay, so take note of this one. These notations we will be using depending on what formula we will be using in the future. Okay, so population, capital N, sample, small letter n. So let's say that here in this data set that we have here, we are, it's just a sample of the entire population. So what is our sample population? How many pieces? Come on, there's only 3 of you. N is
40.
40. Okay, good. So from these 40 samples, we need to divide it into 8 classes. So we need to get your interval or your I. To get your interval, we need to base it from our range. What is our range? Range is equal to highest score minus lowest score. So HS is what? Get
97.
your, okay, 97. Actually, I haven't answered this one yet. So I am going to rely on you. Lowest score,
50.
50. Okay. So our range R is going to be equal to
47.
40. That is now 97 minus 50. So range is equal to 47. So to get our interval I is equal to the range bagi number of classes. So we are given 8 classes. So I is equal to 47 divided by 8 classes, giving us One,
5.8 something.
4.8 something,
5.8.
5.8 something, according to Brian. But okay, it's okay if it is not accurate over here because we usually round it up. We round it up to 6. Okay? As long as there is a decimal, we usually round it up. So what's the next step? Where do we start in making the table? Come on, this is a recall lesson, so you should at least remember something. Where do we start?
The
Where? We start from the lowest is score. Lowest score is 50, okay? So 50, and then as we go up, we add the interval plus 6. So 50, the next class is, starts with
56,
56, followed by
62,
2, 68, followed by
74,
74, 80, and we do this until we reach 8 levels, 8 classes. Okay? So 1, 2, 3, 4, 5, 6 means 2 more. 86 and
92.
92. Okay? Clear? So this is now going to be your first column of your table. However, this is an interval. There's a range. Okay? So this one, 50 until, what number is this
55.
one? 55. Okay? And then this one is 56 until 61. You can do this by just let minus 1 from here. Okay? So this one is 62 until
67.
67 until 73, then until 79. This one is 85. Next will be 91, and this is going to be
97.
correct, 97. Okay? If you check the distance between these numbers, it is also I. Okay? Got that? Okay. Next. This is now our X values. Okay, at this point, I want you to transfer the information by getting your tally. Tally the info. After tallying the info for the data, we get the frequency F. And after doing the frequency, we write the cumulative frequency, less than cumulative frequency. I'll give you 5 minutes to complete this part of the table.
Hey, teacher.
Okay, this is 89, yeah? This one. This is 89 there. Okay. Can you give me the frequencies that you got? You done? Okay. Let's see and compare. Help me out. Frequency. What class? Again. 4. Continue. 12, 7, 3, 4, 2. Brian, can you confirm?
Yeah, I got the same.
Get the same? Okay, so the tally should be, obviously, it will be 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 1, 2. 1, 2, 3, 4, 5, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 1, 2. Okay, something like that. You can check if you got everything by summation of f. Summation of f, if you add all of this, you should get the same number as that. That's 40. Okay. Cumulative, less than cumulative frequency starts here down below. So you start with 2, slowly adding up, going here. So this one is 2, followed by followed by
4,
4, followed the next will be
8,
8, 11, 18 plus 12 will be
30,
30, 36, and then 40. So this one, the same as that, the same as that. Okay, we are in the right track. The problem here is the difficulty about this presentation is that if you make a mistake in your tallying and your frequency, everything becomes wrong. All your calculations from your mean, median, mode, quartiles, everything until variance is going to become get the mean, okay? So the next part here is your boundaries, okay? Your boundary, you have your lower boundary and your upper boundary. And to do that, usually you just find the limit between this until there. Point 5, 73.5, 67.5. Put everything? Yeah, okay. And the upper boundary is you add 0.5 to this. So it will be 97.5, 91.5, 85.5, 79.5, 73.5, 67.5, 61.5, and the last one is 55.5. So that is now the next column. Next after that is going to be the midpoint, M. For the boundary, I'm just going to transfer it there. Boundary, you have two types. You have the lower boundary until this one is the upper boundary, UB. Okay. What's the midpoint? It's just the average between these two values, or you can also take it from the X. This is now the average between these two. Okay. What's the average? You can start here down below. Easier. It is going to be 52.5.
52.5.
Yeah. Okay. So next one is
58.5.
58.5. The shortcut is once you get the first, you just add I going up the interval. So 58.5 plus 6 will give you
64.5.
64.5, 70.5, 76.5, 82.5, correct?
Yes.
Yes, 82.5, 88, 88.5, and the last one will be 94.5. Okay, after the midpoint, we can now get our F times M, frequency times M. Get your midpoint, kali the frequency over here. Okay, please do that. If you know how to use Excel, this one will be easy as long as you can enter the formula. Okay, anyone? Frequency or F times M, top value over here? Three, 7, 8. Give it to me in digits, easier for me to understand. Next, 5, 3, 1. Next, 990. 535.5. 211.5. 258. 117. 105. Okay, so this part we need our summation of F times M. Add all of this. Summation is can someone confirm?
So,
Same?
yeah, it's same.
Okay, so with this one, we can now calculate our mean. Okay, for our mean, that is going to be summation of F times M over summation of, okay? That will be 3126. 3126 divided by 40. So our mean is equal to
It's 78.15.
78.15.
15.
0.5. Okay, 78.5. That is now the mean. Celine, same. Did you get the same?
15, teacher.
0.5.
15.
1.5.
0.15.
Oh, which one?
Yeah, like that.
This like this. Okay, so 78.15. And this is the mean. We can get an actual value for the mean, but for median and mode, we can, the easiest one that we can get is our median class. Median class. How do we get the median class? This is just the class, not the actual median. We cannot actually find the actual median. Okay, median class is what? It will now be we base it from the position, median position, and divided by 2. So that is now 40 divided by 2, which is going to be 20. 20th position. Where's the 20th position?
At the in
Basic.
between 80 to
Which one?
85.
So it is the class 80 to 85. Correct? Okay.
Yes.
So this one now, for the median class, it is now 80 to 85. That's the answer there. We can also do that for our modal class. For our modal class, highest frequency, 12, which is still the same, 80 to 85. Okay, clear? Next. However, sometimes we need to be more specific, okay, with our data presentation. So if you know the median class, then at least give us an idea on what is the median or what is the mode. So since this is group data with the interval, what we can present them is going to be our estimated, okay? Estimated median or mode. For estimated median, we have a formula. We can get this two ways. Either we get it through the formula or we take it through interpolation, okay, or ratio and proportion. So for estimated median, we have the formula median. MD median is equal to lower boundary of the median class plus summation of f over 2 minus less than cumulative frequency of the lower class divided by frequency of the median class kali I. That is for the estimated median. We also have here the estimated mode. For the estimated mode, it's a bit more complicated. MO mode is equal to lower boundary of the modal class plus D1 over D1 plus D2 times I. But what is D1 and D2? D1 is, where will I write it? Okay, D1 is frequency of modal. It's not the less than cumulative. Okay, so frequency of the modal class minus frequency of the lower class. And D2 is equal to frequency of the modal class minus frequency of the upper class. Okay, let's calculate. Let's calculate. So go through the data. Estimated median, that will now be median. MD is equal to lower boundary of the median class. Take note of our median class. Our median class is 80 to 85 here. This is the data set that we are going to be looking at. So it will be here, here, here along this line. Okay. Lower boundary. Anyone?
79.5.
Okay, 79.5 plus summation of f over 2
20.
Summation of f is 40 divided by 2 will give you 20 minus less than cumulative frequency of the lower class will be
18.
this one, 18 divided by
12.
frequency of the median class, 12. Then kali number of interval, 6. There, okay? Get your calculators and give me the value for the median.
80.5.
80.5.
Yes.
Okay. So it is still within this value over here. So that's it. We can also get the estimated mode. Estimated mode is you need to start with the D1 first. D1 is frequency of mode, frequency of modal class. Yeah. So we have 12 minus frequency of the lower class, 7. 12 minus 7. 12 minus 7 is 5, correct? 5.
Yeah.
D2 is frequency of modal minus upper, minus 6. Will give us 6. Applying the formula, that will now be estimated mode is equal to lower boundary of the modal class, 79.5 plus D1, 5 over D1 plus D2, so 5 plus 6 kali I interval 6, and the mode is going to be what?
82.23.
82.23. Okay, so this is now using the formula, but this formula is only limited for the median, estimated median, and estimated mode. A more general approach to calculating this is what you call interpolation. Interpolation, which is now a ratio and proportion approach. And you can use this approach to solve for other details like quartile 3, quartile 1, so that you can get your interquartile range. And you can also use this one for your percentile, okay? I do not have actually enough time to discuss this or use it, but I'm just going to go over and show you the visual presentation of it. So here will be the X, and let's say you are solving for the median. So this is now the median position. This value over here will be our less than cumulative frequency of the lower class from the median. This one is the less than cumulative frequency of the median. Up here will be your boundary. We have here your lower boundary, and that is now your upper boundary. What you do is to make a proportion, meaning this to this. Okay, this one bagi this one divided by this is equal to this one divided by that one. Okay, and then we just solve for the value of X. Okay, it is already time. Maybe I will demonstrate how to use this by next meeting. Okay, so you can now move to your next class. Goodbye, everyone.
Goodbye. Thank you, teacher.
Thank you, teacher.